This project might be one of the most interesting embodied AI systems I've seen recently. It was developed for Google's Gemma 4 hackathon, and the idea is honestly pretty wild. The team took Gemma 4 and embodied it into a wearable, robotic arm system built around a Raspberry Pi 5, a Jetson AGX Orin, onboard cameras, local battery power, and a robot manipulator mounted directly to the user's belt. The entire system is portable and self-contained. There's a LiPo battery pack in a waist pouch, a DC to DC converter powering the electronics, a physical emergency stop button, a body-mounted GoPro for environmental awareness, and even a wrist-mounted camera attached directly to the robot arm itself. The AI can process voice commands, observe the environment through multiple camera feeds, and learn physical tasks from human demonstrations. And what really caught my attention is how all of these components come together into a single, wearable, embodied AI platform. This isn't just a robot arm sitting on a workbench. It's a fully wearable robotic assistance system designed to move through the real world alongside the operator. The project is called Gem 4, and the entire hardware stack, software pipeline, and bill of materials are openly available online. The links are in the description.
How does Gem 4 understand a task and move the robot? Gem 4 uses voice commands, a wrist camera, and a chest camera. On Jetson AGX Orin, Gem 4 understands the scene and instruction. With bridge attention and an action head, it generates robot action data. Mimic Rec converts that data into real robot motion. But a static model is not enough for real-world deployment, so Gem 4 is built around continuous learning. Mimic Anno turns human demonstration videos into task-labeled robot action data using depth estimation and hand pose estimation. Mimic Rec records direct robot teaching, including camera input, trajectories, joint angles, gripper motion, and video data. These datasets can be saved to Hugging Face and used to fine-tune the model. As demonstrations increase, Gem 4 keeps learning, and Gem 4 becomes better at assisting people.
This is the write-up for this project, the Gemma Embodied for Physical Assistance. That's the name of it here. And of course, I'll put this link in the description so you can peruse it at your own pace. I'm not going to read all of it, but essentially, I'll read this first part. So much of daily life assumes that people can freely use both arms, locate objects in front of them, and reach naturally for what they need. For people with visual or upper limb impairments, this assumption does not hold. This project develops a wearable VLA, Vision Language Action Assistant, based on Gemma 4 that serves as a second arm for these users, together with the data collection, generation, and annotation infrastructure needed to train it as an integrated system. Okay. And so basically they're explaining why they chose a wearable form factor, some challenges it introduces, and then so they have the model and data as two different pillars. Okay, that makes sense. And so apparently it's capturing data while you're using it so it can get better over time. And then, they're uploading the data, and that's all automatic. It's got a, diagram. They got a flowchart diagram here that kind of explains everything in more detail, which I'm just going to kind of brush over all this. I just want to present this project because I saw it. I thought it was pretty cool. Came across it on YouTube. And somehow it was posted on a channel that has less subscribers than I do. So I was like, maybe I can give this project a shout out. And it looks pretty cool. It's like a Dr. Octopus, from Spider-Man, Doc Ock. It's kind of like that. If you added 3 more arms, you'd be like you'd have 4 arms plus your 2 arms. So, all right, enough rambling. Here's the GitHub. Put this link in the description as well. All right, and it kind of says a lot of the stuff actually looks like exactly what's in the write-up. Except down here we have a hardware bill of materials. I'm not sure if that was in the write-up. It might have been. I don't know. I'll put links to both in the description. And so as you can see, It'll cost about $4,000, depending on where you get the parts from and, you know, all that. But basically, you need a wrist camera, and they used an Intel RealSense D435i. They used a GoPro for the chest camera. Then a DC to DC converter. Because the Jetson's going to be using 19 volts apparently, and then the Raspberry Pi, I believe, is 5 volts. So you got to have something to convert the power from the battery. So you make sure all your devices get the correct amount of voltage, because you don't want to just send the same amount of voltage to everything. So that'll be pretty bad. But yeah, DC to DC converter that can change your voltage signals and, you know, drop it down from where it needs to be. Apparently it's dropping it from 24 volts to 19 volts, and then also to 5 amps, and then may adjust the wattage as well. I'm not sure. Moving on. Let's see. NVIDIA Jetson Orin. Okay. And then they use the Rebot arm for the robot arm. And I actually have that pulled up right here. So apparently it is open source, so you can download all the parts, so you can build it yourself. Well, it's 3D printed for the most part, but you do need some screws and probably a few other metal parts. Unless you can make your own screws, which would be pretty cool. Well, then you need some actuators and a driver board and a power separation board. Basically, you need something that will let the battery and all your motors can communicate without frying each other. So that's the thing, if you plug in a battery to a random motor, you might end up just frying the motor, and it's pretty easy to do that actually. So that's why you need something to convert the DC to DC converter. All right. So enough rambling about that. What was the price for this? Oh, lost the price. Damn it. Oh, there we go. Okay, 1,197. Well, that's kind of steep. And if you built it yourself, I don't know, maybe it'd be cheaper. Looks like they've got different kits too, if you just want to buy part of it and put the rest together yourself. Okay, so that's it right there. The Rebot looks like a fairly basic arm. That's what they used. And yeah, that's pretty much it in a nutshell. I mean, I think this is a pretty cool project. I would definitely recommend trying it out if you have a few grand, or if you already have a robot arm, just, try to connect it to a battery. So the cool thing about this is that I can actually take voice commands. You could say, like, pick up the bottle, and it will, figure out what you're talking about because of all the software, Mimic Rec, and the Gemma 4 language model that all communicates to kind of figure out what you're talking about. So I'll probably butcher the explanation, so I'm not going to try to explain how the software pipeline works. I'm just presenting this whole project, trying to do it quickly. And yeah, let me know what you think in the comments. Let me know if you'll build one yourself. Let me know what you would do with this robot arm. What would you grab if you had an extra arm attached to your body? Alright, that's all, folks.